So here in this video we are going to discuss the concept of stereographic projection. Okay, so what is actually stereographic projection? So we can think about the complex plane, that is our xy plane. Okay, and corresponding to each point of this complex plane, we can have a point in a sphere. That is, there exists a one-to-one correspondence between a complex plane and a sphere. Okay, so conversely also, if I consider a point in the sphere, then you can have the corresponding point in the complex plane. So we have this one-to-one correspondence. So for this one-to-one correspondence, we can think about this complex plane in terms of actually spherical representation. Okay, so that is, the complex plane can be discussed without considering the concept of R. Actually, that is the set of real number. Okay, so before going to this main discussion, we need the concept of infinity of complex plane, that is the Z plane. So if you remember from real analysis, or in a set of real number, okay, or the real numbers and the real lines in a real line, there are actually two infinity. One is actually plus infinity, and other is minus infinity. Any real number lies in between minus infinity and plus infinity. Okay, so why it is happening? Actually, because we have the concept of ordering in the set of real number. Set of real number has the ordering, that is, we can compare any two real number. If two real numbers are there, then one is either one is greater than or less than. Okay, this is actually happening in case of set of real number. But in case of complex number, there is no ordering. There is no ordering in case of complex number. In the very beginning of that is in the first class in our discussion of this semester, we observed that there is no ordering in the set of actually complex number. Okay, so that is, you can't compare two complex number. That is, you can't say that Z1 is greater than Z2 or Z1 is less than Z2. This type of concept is not there in case of complex number. Okay, so since this type of concept is not there, there is no ordering, so we don't have this concept of plus minus, plus infinity and minus infinity. Okay, so we have just only one infinity, which is actually the which is known as complex infinity. Okay, we have only one infinity. There is no two infinite infinity. In case of real number, we have two infinity. One is minus infinity, and other is plus infinity. But in case of complex number, there is no actually ordering. Therefore, we have only one infinity. Okay, so that is the concept. That is the notation we need actually. We need to discuss the concept of this stereographic projection. So we are going to consider the complex plane C is extended. In case of real number also, infinity and minus infinity are said to be extended real number. So here also actually complex plane, we have this complex plane, that is the xy plane, okay, or z plane, is extended by adjoining one extra point called the point at infinity. Okay, we are going to introduce this extra point, that is point at infinity. So to discuss the concept of this infinity, we have some notations, we have some observations. So we have some agreement. What is this agreement? If z by infinity, this is equal to 0, z plus infinity equal to infinity. If z is not equal to infinity, z by 0 is equal to infinity, and z into infinity is equal to infinity if z is not equal to 0, and z by infinity by z is equal to infinity if alpha z is not equal to infinity. Okay, so we have this type of actually concept for insight for this infinity, but we don't have this type of actually concept in case of infinity, 0 by 0. Okay, we don't have this alpha plus infinity plus infinity, infinity minus infinity, 0 into infinity, and infinity by infinity. We don't have this type of concept. And now we're going to define this. Again, we can define this is the concept of 0 to the power minus n. So 0 to the power minus n, because 0 to the power minus n is nothing but something like the alpha to the power n. Okay, alpha to the power n, this is equal to infinity. Infinity to the power n, this is equal to infinity. And 0 to the power n can be written as infinity to the power minus n. Okay, but infinity to the power minus n is nothing but 0. Okay, so therefore we are going to agree this infinity with this concept in terms of complex plane. So how can we get this actually, the one-to-one correspondence between the set of complex number, that is between the set complex plane and a sphere. So let's see with the complex plane, that is this plane. See with the complex plane, that is this is xy plane, this part. Okay, this part xy plane, xy plane. Okay, see with the complex plane. Okay, xy plane. We are going to consider this plane is equal to alpha beta plane. So this is alpha axis, this is beta axis for our discussion. So let's see with the complex plane. Through the origin, construct a line perpendicular to C. So this is the line which is perpendicular to C, and we are going to call this line as gamma axis. Okay, let this be the gamma axis of a three-dimensional Euclidean space in which a point has coordinate alpha beta gamma. We are going to consider the point coordinate of the point as alpha beta gamma. That is, we will consider this as alpha axis, this as actually beta axis, this is actually gamma axis. Now you consider a sphere as of the radius half and with center at 0, 0, half. That is, sphere means it is the collection of all those points alpha beta gamma in R cube satisfying this condition. Okay, so sphere that is center at 0, 0, half and radius half. This is the standard equation of a sphere where the center is 0, 0, half and radius is half. So that is, we are going to consider all those points. These are actually alpha beta gamma, these are actually real number in R cube. Okay, this is the collection of all those points. The point n001, that this point, okay, I am going to consider this as dotted line because we have to consider in the upper part, and the z-axis, that is the gamma axis, through the actually center of this sphere. Therefore we are going to consider this gamma axis as dotted line. Okay, because we have this part. Okay, this part is there, this part. So the point n001 is called the actual north pole. This point is said to be north pole, and the point S and the south pole of S. Okay, and 0, 0, 0, 0, this is the point 0, 0, 0 is called the south pole of S. This S is the sphere. The great circle, this is the great circle, that is the circle whose passes through the center of the sphere is said to be great circle. The great circle, this is gamma is equal to half because this is the center 0, 0, because radius of this sphere is equal to half. Therefore the equation of this great circle is equal to gamma is equal to half. Okay, gamma is equal to half. Okay, so gamma is z equal to half in terms of z, x, y, z coordinate. Okay, so this is known as equator. This great circle is said to be actually equator. Okay, equator. The plane gamma is equal to 0, that is, we don't have this value of gamma, coincide with this. The plane gamma equal to 0 coincide with this xy plane. Okay, coincide with this complex plane. Okay, complex plane, that is this, and alpha beta axis are the x axis and y axis. Okay, alpha beta axis are the x axis and y axis. Okay, so if I consider pxy 0, qxy 0, this is a point in this complex plane. Okay, now you consider this north pole of this sphere and join this is dotted line because this is from this line passes through the center through the center. Therefore it will be in this part. Okay, inside this part. So you consider this dotted line up to this surface P. Okay, join this N and Q. If I join this N and Q, then it will intersect at the point P. So for any point in z plane, we have a corresponding point in the sphere which is P. Okay, similarly if I consider a point in P, say, okay, then you just join NP and extend this NP, then it will meet this xy plane, that is the alpha beta plane at the point say Q. Okay, so that is for any point P, you can have a point in z plane. Okay, similarly for any point Q in z plane, we can have a point in sphere that is at the point P. Okay, so there exists actually one-to-one correspondence between the point in the xy plane and this corresponding sphere. Okay, there exists a one-to-one correspondence. Okay, so you see, so we draw a straight line NQ. We draw a straight line NQ intersecting sphere at a point, say P alpha beta gamma, which we have discussed. Then alpha beta gamma is called the stereographic projection. Okay, alpha beta gamma, this point is called a stereographic projection of Q. Okay, stereographic projection of projection of the point xy0 actually on the sphere, and is considered the spherical representation of z is equal to x plus iy, because we have the point, okay, we have the point, okay, xyz, okay, xy, we have the point xy. So this procedure assign a unique point on S to every point Z, so that C is free from R cube. Okay, so first of all we have this point, then corresponding to that point we have the point on the sphere. Okay, if I going to join this N and Q. Okay, so this is known as P is said to be the stereographic projection of Q. And conversely, to each point alpha beta gamma, that is this point on the sphere other than N, forget about the N, we can associate the complex number xy0, that is this complex number, where the line from 001 from here to there, line from 001 through alpha beta gamma intersects. Okay, alpha beta gamma intersect, that is if I am going to extend this point, extend this line, then you can observe this line intersect at a point. Okay, this is CQ, so that is this will be the stereographic projection of the point P. Okay, Q is the stereographic projection of the point P. Okay, so that is you can observe if we have a point Q, then we can have a point P. Similarly, if we have a point P, then we can have a point Q. Okay, so how can you actually represent this concept in terms of actually mathematically, how can you get this one-to-one correspondence? Okay, how can you have this formula? So now you just observe another important thing, if I consider the point P as N, okay, so then there will be actually this concept cannot be actually introduced. For P, if we can join NP and we are going to extend this point, extend this line NP, but this is not possible actually, because we have to join N and N, but this is not possible, N and N, so that is the same point itself. So for corresponding the point N, we are going to consider a point actually which is at infinity. That is the corresponding point for N is nothing but the infinity, the point of this infinity. For all other point, we can have a point on this complex plane, okay, but the point N, there is no actually correspondence for the point in xy plane, okay, in xy plane, in the z plane. Okay, so we are going to consider that correspondence is nothing but infinity. Okay, so the sphere is called the Riemann sphere or complex sphere. So now we are going to this corresponding one-to-one correspondence. How can you give the formula? So line in R cube, the line in R cube passing through the point 001 and xy0 is given by, okay, this is 001, that is the north pole, and any point xy0, xy0 that is in the this point Q actually. Okay, so it's given by, this is the line joining two points, equation of a line joining two points in complex form. Okay, t001 plus 1 minus this, t belongs to R, that is we have to consider all those points of this form, 1 minus t comma x, 1 minus t comma y in t, where t is a real number. Since the line intersect the sphere, okay, this line intersect the sphere, okay, sphere, therefore it must satisfy the equation of the sphere. Okay, so it must satisfy the equation of the sphere. So therefore there is a point on this sphere, so we are going to find out what is that point actually. So this is the arbitrary point you consider, since it satisfies the equation of the sphere by using the equation of the sphere. Okay, so x square plus y square plus something like that, z minus half whole square is equal to 1 by 4. Using that concept, we can have this part. Then x square plus y square is nothing but mod of z whole square. So this is this, but we are not going to consider alpha beta gamma is equal to 001. Okay, we are not going to consider, because then n is the actually north pole. Okay, n is the north pole, and corresponding to that north pole, there is no point on this actually the z plane. The point for north pole is nothing but infinity. So therefore alpha beta gamma cannot be 001. So that is gamma is not equal to 001. So you can actually gamma is not equal to 001. Okay, so this third quotient is not equal to 1. So therefore we can divide this, that is this is not equal to 1, so divide this expression by 1 minus t. Okay, so you can have this value of t, this is the value of t, and this is 1 minus t. Since n, p, q are these are collinear points, therefore you can consider alpha is equal to 1 minus t. The first coordinate is nothing but is equal to 1 minus t of x. This is alpha. Okay, alpha is equal to 1. This is the first coordinate. Alpha is nothing but you can consider alpha is equal to 1 minus t of x. Beta is equal to 1 minus t of y, and gamma is equal to say t. Okay, gamma is equal to t. So just put the value of 1 minus t. 1 minus t is, this is our 1 minus t. X can be written as z plus z bar divided by 2. Okay, or in terms of x, y, z, this is something like that, x, y. Okay, so similarly beta can be written in this way. This is our beta. This is simple calculation, beta, or in terms of z you can write down this expression, or in terms of x, y you can write down this expression. Or gamma, for gamma is equal to t. Gamma is this is our gamma. Okay, that is, if I consider z is equal to x plus iy, okay, the corresponding point is nothing but alpha, beta, gamma. This is the corresponding point, alpha, beta, gamma. This is x coordinate, that is the first coordinate, second coordinate, third coordinate. So in terms of z, okay, if I consider z, then this will be the corresponding point. Okay, now if I consider now 1 minus gamma, so this is, if we have z, then we have this point. Now the converse part. Now 1 minus gamma, 1 minus gamma is equal to 1 by 1 plus z square. So this is mod of z square is equal to gamma by 1 minus z. So therefore x square plus y square, this is equal to gamma 1 minus z, 1 minus gamma divided by 1 minus gamma. So alpha is equal to, that is just in terms of xy coordinate, just put the value xy coordinate, but x square y square is equal to this. So x plus the x is nothing but alpha by 1 minus gamma. Similarly y is nothing but beta by 1 minus gamma. So z will be, actually this is our z. Okay, so if alpha, beta, gamma is given, then the corresponding point z will be this. If a point in the sphere is given, the corresponding point can be written in this way. Okay, so if a point in the complex plane is given, then the corresponding point can be written in this. Okay, so this is the one-to-one correspondence. So in mathematically, that is in matrix represent in mapping representation, what is this actually? The map z alpha, beta, gamma is called a stereographic projection of C on S. You have to delete the point 1, 0, 0, 1, because there is the correspondence of 0, 0, 1 is nothing but infinity, but in complex one there is no infinity. Infinity is the extended complex number, actually you can consider, and vice versa. That is, if pi is a mapping from C to this, okay, is the stereographic projection of C on this, then we can have pi z equal to this. Okay, and conversely pi inverse of this will be nothing but this. So this is the concept of the inside of this stereographic projection. The calculation and mathematics is very easy, but the concept you have to think. Okay, thank you.